Yeah, hello everyone. We will continue our projects on data ingestion patterns. Today it is part 4. We already finished 7 different use cases and we will keep going according to our plan. Let me share the screen and see where we now. This is our repo and this is what we pushed so far. So we search from local Python on the machine, then we run this Python code in Docker container, then we use Lambda, and then we use serverless deploy Lambda. So this is kind of like just use this serverless YAML file to deploy. And then we use AWS batch to run our Docker container in AWS. And this involve ECR, ECS services. Then we use step functions to kind of like orchestrate everything. And we use also event bridge as a scheduler. So, and now we can keep going. See, so we finished those 7. So according to the plan, the next step will be to take our Python code and run it with the Glue uh, shell first. So Glue shell is we'll look what is the Glue service in AWS, and we'll see what kind of options we have there. And then we will convert Glue shell to the PySpark, so actual Spark, because Glue shell it just will run your Python code on the schedule. That's it. On one project, we're using Glue for many jobs, and we trying to migrate Databricks, but we found that the cost for Databricks is so high in comparison with Glue. So we even the company now trying to push back this migration because you don't get much value if you push your jobs from Glue to Databricks, but the cost will rise like 10 times. And then idea was to use Managed Airflow instance to kind of run our Python code. And then we wanted to see Athena, what is Athena service, and query the data. So Athena is mostly for the query data, but you can connect dbt to Athena and build your data lake right in Athena. And then idea was to jump from Athena to Redshift, and we probably were going to use the serverless one. So the difference between serverless and non-serverless, who manage the infrastructure. So if you're using, for example, Managed Airflow is not serverless by default. So it's basically you create couple instance and you pay 24/7 for this. And if you run big job, Python job, and you're out of the memory, your job failed. If you're using serverless, I think the Managed Airflow also allows you to run serverless. If you use serverless, then you don't care about size of the instance, you don't care about infrastructure, it just run. And resources will allocate you by AWS. So that's the difference. So um, it's cheaper. So you pay, and Athena is only serverless. So Redshift has serverless and non-serverless. There is one more service maybe worth to check is Elastic MapReduce. It's also available as a serverless and non-serverless. And then we come to eventually to traditional Snowflake dbt core, and maybe we can connect it with Airflow, like very, very typical solution. And the final one will be, maybe it will take dedicated time um, for streaming with Kinesis. Yeah, and we have dedicated folder with CloudFormations where we create all resources. And I'm using Claude. So this is my Claude file about this repo. And also because it's happening inside Cursor, I have the Cursor rules that will tell you, hey, check Claude rules. And this is just your permission settings. I don't have any MCP set up, but usually the nice MCP you can add, for example, Airflow MCP, Snowflake MCP. There is AWS MCP, but I found AWS CLI works extremely well, and you don't need to do anything at all. So I think here we also highlight what kind of CLI profile we use. So we have AWS profile local. I think this one we created with admin permissions. And then there might be another profile specifically for the project itself. Or maybe not. No, it's only local. Okay. So let's start. Let's log into AWS. And if I go to the Glue, it has several things here. So it has ETL jobs, the one we're going to use for data ingestions. It has data catalog. So it's overall catalog idea because this is same as Hive metastore, for example, or Iceberg catalog. So just the catalog that register your metadata, database, schemas, tables, but your data physically stores in S3 bucket in case of AWS. But because you have catalog and you have reference, so you can write the SQL against those tables. But technically, you will query S3 bucket. Data connections, you probably you can create some connections to databases, you see to the services, and just leverage them. Zero ETL integrations, I think that's idea. If you're running any AWS service, like database, and you want to leverage it, and instead of building traditional ETL, copy physically the data, you can just kind of like able to access these somehow. Or maybe, I don't know, the data will automatically copy for you. So, but zero ETL means you don't need to do anything. You don't need to really manage anything. And so these catalogs, the nice service, the crawler, is quite popular. So crawler, what it does, if you have data, for example, you have the Python script that dump data into S3, and you want to register the table in the catalog. In our case, it will be Glue catalog, and it's very similar to Hive. It's a managed catalog. And you'll see all the catalogs. The Glue crawler will just, you tell, this is my bucket with JSON files. It will scan the bucket, and it will take the sample of data, and it will understand the structure, and it will create the table for you. That's how it works. So pretty easy and straightforward and very convenient. In some cases, you can do some kind of automation, like auto discovery for the new data of schema change or something. But so it's basically just very helpful. As soon as you put any data in S3, you can create the table and maybe query it later with Athena, and it will automatically understand like number of columns, their data types, and so on. It has data integration. It has many more things, but for you, probably the two most important things is the crawler catalog itself. For example, right now, this is probably my account ID, but I don't have any catalog yet, any tables, and the jobs. That's it. What you need. So if I go to here, it has visual ETL, and this is kind of like you can drag and drop components. For example, I want to add S3. Every time and I can say, oh, where is my S3? Where is my data? And I can do, if I go here and find something I want to find, maybe I will, this is my source. And I can say CSV, and I can intro the schema if it's, I know what. I personally never use the visual thing. Oh, it's required the role. Yeah, and this is what we have. Um, and you see, it's basically automatically generate the PySpark for you, and even we can just use it, just in the past. Then we didn't have any EI. I would come to here and generate a bit of code and move it to notebooks. But here, the one important thing about Glue. So traditionally, then you work with Spark. You have Spark sessions and data frames, but like the Spark context, this is default for any Spark in Databricks as well. But Glue has own context. And they also, instead of traditional data frames, they have dynamic data frame. So if we'll ask AI kind of like, what is the difference between GlueContext and SparkContext? I still, even if I'm using Glue, I don't use GlueContext because the syntax is different. And yeah, usually you can convert from one to another, but I don't know the benefits. So maybe AI will help us to see the difference. So yeah, they have this dynamic frame, and like schema might be flexible versus a traditional data frame in Spark. It's strict schema. It works with built-in connections. Okay, that's if you want to use this probably menu with connections, you need to do this and better handle the schema changes. So, and it also has the Glue job marks in case if you're loading like incrementally. In case of Spark, you need to develop something yourself. Yeah, better doing AWS CloudWatch. But I think the Glue itself has integration with CloudWatch. But yeah, if you want any specific logs, so I need to import logging library and do these log lines in the code, like across the code to make it working. Yeah, but still, I will prefer traditional one because in case if I switch Glue to Databricks, so I will do just pure Databricks or pure Spark, it is clear for me. But it's good to know the difference between them. They exist. Yeah, and typically what's happening here, you can build your jobs, and then you can come to here. You can choose the worker type. You see, it's like t-shirt sizes, like how big you need. And this is the biggest challenge with Spark, to choose the right cluster size and type and size and number of the nodes. Recently, I had one example, one person in Databricks, analyst asked me, why do I need to use serverless? I want to use my own clusters. I want to create clusters. And I thought, okay, here's the trade-off. With serverless, you don't care about the size of the node, type of the node, and number of the nodes. As soon as you start using your personal clusters, and here in Glue, you have very little number of things. In Databricks, I know, will it tells you, I don't know where they keep them. Dynamics. They have so many. They have this number of types like general purpose memory optimized, storage optimized, compute optimized, GPU, and also for every You see how many sizes you have each of them. And then some kind of analyst will ask, I want to create my own cluster. The challenge is they might choose, okay, I want to use this one for my job. The problem is because it's distributed computing and you need to make sure your data, for example, in S3, is suited for this kind of compute because you have multiple nodes. Your goal, you have many nodes, they work in parallel. You don't want to have situations that you have, I don't know, 12 of those expensive nodes and you have two big Parquet files in S3. It means only two nodes will work, everyone else will be stale, but you're going to pay for everything. That's why the tuning of Spark is really complicated. You always need to look the query plan. You need to look to the metrics, Spark UI, to see utilization of your nodes, to see are you underutilized or overutilized. And the same applicable for Snowflake still, because even if it's fully managed service, it's still sometimes you can choose the, I don't know, large cluster, large compute, but if you check the queries, like it's underutilized. So maybe you better switch to medium, or instead having 5 small warehouses in Snowflake, you can use one medium, and this is trade-offs that data engineers need to go. And this is extremely well use case for the interview. If you can prepare and talk this kind of use case, then I understood what's our compute patterns and how I can make them better. Yeah, and this is how, but if you going this path with Glue, you will probably do some kind either CloudFormations on Terraform, because just remember, like CloudFormation, Terraform, you can create any resources and you can schedule. Here you have some advanced property options, but this is UI, and you have data quality tab. I never use the data quality, but there is. You can add the schedule, and you can have the run history. So that's about visual jobs. Then you have options to use notebooks, and the last one, script editor, is probably Glue shell. Maybe no. Yes, then I have script editor. I can choose Spark, Ray. So it's another, I think, language for Spark, good for machine learning, and the Python shell. So the Python shell means it's just a little compute environment to run your Python. So it's the same as a Lambda, but without challenges with timeout. So it's like more heavy compute environment. And here we can put our Python script and run on the schedule. So really nice options to run your job. For example, one of the jobs we using AWS Athena. It means you can run SQL. And instead of dbt transformations, we using Glue shell, like the same environment, to execute the Athena scripts on the schedule. It's a kind of like store procedure inside in the Python environment, and you just you wrap your all the SQL transformations here, and you run your job on the schedule. So using the Python wrapper just to execute your Athena on the schedule. And as you know, on the previous examples, you can use Lambda, you can use batch, step functions, like all those services, they are interconnected. The same, you can use Airflow to run all of this. So what we're gonna do, we will try to create a new job for Glue shell first to query our GitHub stuff. So in here, okay, I don't want this. To work on Yeah, we want to create glue shell job to run a simple Python script to pull data from P and save into S3. Use CloudFormation to create glue job and use, I think we have it, and use simple Python from so that the work of data engineer is right now is very simple. I can give instructions to this thing to run. Even I can do, yeah, the plan mode is good. It's actually saving time. And I use the Opus model now. So maybe I can use the Opus to build the plan and then switch to Sonnet. Okay. But the key here as a data engineer is coming to system design, because I need to decide how we're going to do this and what are the potential challenges. Because challenges could be, we have any rate limit for API, or maybe our organization is using Fivetran, like then we don't need Python. Or like this, all these options. You need to be confident with the options you choose. If you don't know, again, you can chat with AI. It will outline you all the options, and you can choose the best options for you. So it will now trying the plan, and maybe right in parallel, we can do same, but for Spark. In this scenario, I want to hit a new Glue Spark job to get data from GitHub API and save into S3, similar to create a new formation for glue job. And we're going to use plan mode. And since now we let AI thinking for us, we can start tackle this one. I want to create the smallest possible Airflow instance in AWS. Like probably it's XS. And make sure I have a new DAG. Oh no, I'm too fast. And I want to have a DAG to run Python to get data from Hub API and save in S3, and also have the logging and no schedule. Okay, and schedule once a day. Use these Python because Airflow will be more expensive than Step, Batch, and so on. but it's more like proper data engineering thing. So if you're not paying out of the pocket, use Airflow. If you're really sensitive on the money and your Airflow is very expensive, then you need to go to like step, batch, those kind of things. Or if you're doing your personal projects, it's cheaper to run Airflow locally. So for example, I have local instance of Airflow free on my machine for running my jobs. They're not that critical. Add CloudFormation into, and I also set the plan mode. So now we have three options. So it wants to use pandas. So it's telling me, because we're using, I think, rich library, it wants to install like additional things. With Glue, if you want to install additional package, I think it's a bit complicated. It's possible, but takes time. So I will. Um, I will remove reach. iOS Glue need a role trusted Glue. Okay, it will ask use existing role, create new one. Yeah, roles are free, so we can create new role, submit the answers. So boom, it's doing. Okay. It also it's this now it only asks about role. Okay. How should PySpark job produce the S3 output? So it asked me, do we want to do CSV or partitions? Because in Spark, obviously, we work some usually with Parquet files. Yeah, let's try partition output and see what it takes. Yeah, the smallest one is the micro. And you see the micro costs $90 a month. And I'm not sure why we need not. Let's ask. Uh, what is not and why do we need it? So NAT is the AWS service, network address translation. So it's talking about private subnets. Yeah, I know it's private, but why we have the private? Oh, maybe it tries to create Airflow in the private subnet without internet. So I want to have it in public subnet. And it's good that we ask for query for the plan, because otherwise it will go ahead and create this Airflow in the private subnets and not, and we don't need it. Because the key thing in AWS for everyone, understand what is VPC, what is private and public subnet. If you create resources in the private subnet, how you're going to access them. And then, I think it's like those IAM roles and policy permissions. So that's simpler. I don't understand why workers might be in private subnet. Um, It tells if it's expensive, try to use event bridge and Lambda. No, okay. So it tells me Airflow, Managed Airflow work is always in private subnet. So it was okay. Yeah. So it still has this. Okay. So now we have time. It's gonna build. Should create the free labs itself. Athena data lake. And then we can add extra step. Maybe we can try to add Athena. I want to add Athena to be able to query the data that will be reduced by my ETL jobs and stored in S3 bucket. I can also actually check if I go to S3 and see, do I have any other data set that I can, basically I can tell the whole thing, register in Athena and Glue catalog some tables, but I need to tell what it will be. What do we have here? Oh, for example, we can try, assuming I have this one. So this one I create the API script in Airflow to extract all message history from the Discord for some time. Then I can tell, okay, so you can explore JSON file structure and create a table and database in Glue catalog to be able to query these data. And what else? Yeah, use CloudFormations to create. Right now, for anything in cloud to create resources, I always rely on some kind like scripting, Terraform, CloudFormation, Bicep, and so on. And the nice thing about this, I trust a lot to AI to build it for me, and don't need to learn myself like deep Terraform. Just maybe understand the core concepts. What is it? But don't need to actually like understand every line of the code. To create CloudFormation for Athena and DDL tables and SQL queries to query sample data. You can use AWS CLI to analyze the data and so on. Again, I will put it in the plan mode because you can ask some additional questions, and we'll see how these things go. So it's still doing. Oh, this one, the finish. Glue Spark is finished. Yes, you can deploy AWS CLI local. We see how many things it created. And they adding more files. So they adding one file for Glue Python shell. They creating new role. Okay. Yes. It tells the plan what it's gonna do. It's actually building this. So it will create new YAML file. So it probably will create new VPC. And this one, I'm not sure why we need new stuff. Because VPC costs money. I found recently that when you run VPC, it costs money. So it would be nice after the exercise to tear down everything. And that's why this is another reason to have it defined as a code, because I can, whatever I'm going to create here, I can let AWS to destroy it. And that's the thing. So it will create new DAG on GitHub ingest.py. And GitHub to S3 DAG.py. So this one is a helper. I don't know why it needs helper. It will also add requirements.txt file. There we will tell that we need to have a request and bota free. And this is part of AWS, Managed AWS deployment, that you manage requirements file. Okay, it's building. And here for Discord, it asked me, yeah, I can see the data. Pretty printed JSON arrays, which I think can't read it needs JSON object per line. Okay, it doesn't like my JSON files in S3, the format, and it suggests me what to do. I can convert to the Spark. And then ask where Athena should save query results. It also requires the bucket. Partition projections, nice thing. Traditionally with Hive, when you specify partitions, you need to every time like update the metadata to, for example, you run ETL for the week, and every day is a partition. By default, in Hive, for example, those partitions not clear for Spark, or in case of Athena, Athena doesn't know that you created new subfolders with partitions, and they have a very nice feature that calls partition projections. So this is the property of the table where you can say, yeah, all my partitions will have this kind of format. It's like year, month, date, and it will automatically auto-discover them. It's a really nice feature. Maybe you have any questions while we doing this thing. So it tells me it's create the Glue job for the shell and for Spark, and we can test it and see. Oh, interesting. Where is it? Okay, it put this in US East 1. Yeah, this is the script that was created. And you can see it's just the Python script. Going to GitHub. This probably the specify AWS secret where we save the token, but we don't need it. This is the logging inside the Glue, just the logger library. This is how you usually define the schema. This is usually for the Spark, but this probably just works for anything. So can check the job details. Everything was created with CloudFormation. So it takes the Python 3, the Glue version, now available like even version 5. Role. Oh, a type is actually Spark. Interesting. That's something we need to double check with AI. Why it's using type Spark, not the Python shell. Oh no. Yeah, this probably this one. Yeah, that's the this the second use case. This is the Spark. That's right. So this one, the Spark. That's why we have all the PySpark here libraries. Yes. But we also should have the shell one. So we can try to run it. I can click run here, or better, I will ask use AWS CLI to run this job and track the status. Because if something fails, AI will know about this. And here I can do the same. Yes. Yeah, the one thing about managed AWS, it will take like 20, 30 minutes to deploy. So while we're doing everything else, it can be deployed. And again, the code is here. And if you're going to AWS Managed Airflow, okay, not to here, but one can see one of the key difference of AWS Manage that it's syncing all the DAGs from S3. Because traditionally, your Airflow, if you deploy it on the ECS, it has the integration with GitHub and like just the main branch, and it's pulling every 30 seconds, the scheduler pulling from GitHub. So here they change it. All your DAGs are storing an S3 bucket. And it means if you push the code somewhere, you need also in GitHub, you also need to make sure you save this code in S3. On the other hand, what I did in the past, for all dbt models, if I wanted this Airflow running my dbt models, I can save them in S3 as well. And it was actually very convenient because otherwise, to run dbt with Airflow, you need to create Docker image with dbt in ECR, push CCR, and then Airflow will run ECS or AWS batch to take this image, start it, and run dbt inside. So it saves a lot of services. So it's, but many people don't like it. You see this that's showing it's syncing, but it also has integration with CloudWatch. It has integrations with secret manager, so you don't need, if you store connections, credentials, you don't need anything. And you don't really care about here. If you just out of the compute, you just double the instance size. Tutorials, they have tutorials. Or it's even one tutorial for VPN tunnel. So it means you probably can access like bash to worker nodes. Code examples, best practice, performance tuning. And there are two options available. There is option free, version 3 and version 2. So there are some configuration things. Again, AI, just fit this to AI, it can help you. Manage Python dependency. Yeah, that's in requirements txt, you can place icon this sync. So to highlight your Airflow version and the Python version that you're using to make sure that all the Python version things is actually works with this Airflow and this Python. For monitoring and metrics, you can have like CloudWatch, you can see how things works. In my experience with Managed Airflow, the most common error message I had for the big jobs is timeout. Or if I have many DAGs with many tasks, they can collapse. They just, if something crashed, it means worker crashed and other DAGs that running on this worker will crash as well. So the only issue I have. Okay, C runs. You see that it runs finally. Whatever I ask, it runs. So this is how Spark job. Um, and this is the like script because you remember we had the options with notebooks. So then you want troubleshoot anything or develop something, you're gonna run the notebook. So if I will create a notebook, I can say, yeah, let's use this role, let's create notebook. And then I can copy portion of the code and you'd like step by step doing discovery. It's like traditional Hex or DeepNote notebook or Jupyter notebooks. And nice thing about Glue notebooks, I can connect them from VS Code notebooks, or I can running the local Jupyter notebook and also doing the troubleshooting like exploration. You don't need UI. Yeah, but nice thing, it succeeded. We can see this is what kind of arguments it takes. It's the same as a Python script argument. So we give the target bucket. This one, you see, we additional Python library, and we pass the like this secret prefix. Yeah, let's see logs, what we have for logging. It's probably like some technical logs. Run insights, no metrics. I think for the metrics, you can also run it locally. We don't have anything. Maybe we need to enable this Spark UI. Yeah, for Spark UI, I remember to basically there's all things like deep dive, how the job perform, if you have multiple nodes, how they working and so on, how many stages, task. You can run it locally, but you need to do some extra things. One nice thing about Glue, um, if you want to build like CI/CD process and you want to test your Spark jobs, like in your, for example, Docker environment, with the way uh, Glue Docker image. Yeah, that's the thing. And we did this in 1Password. So you basically you can download image from ECR or in part of your continuous integration step. You can start it and you can run like your, for example, you change the code and before you merge, you want to test it, it's working. But because you have Glue, obviously it has many different requirements. You might use traditional Spark, but you to map it 100%, you're gonna use this thing, and you just take the image and you can run this image locally in the Docker. So it's exactly the same Glue Spark, or you can run it in, for example, GitHub pipelines or these like actions, GitHub actions, like just as a Docker image. It's heavy, but this is how you're doing your continuous integration process for Spark. Yeah, that's good to know as well. Do I have? I don't have schedules. I have. Yeah, that's it. What we need to know about these, and then we had. Yeah, notebook is started. Yeah, you see, it's very common. So I can just execute this. Probably it tells me the role that I'm using. It missing this I'm pass role. So if I can fix it, I don't want to do it now, but basically I can copy paste this to my CloudFormation stack. It's gonna update the role and I can use it. But this is where we can troubleshoot our code and we can run it from the local. So we can just open the Jupyter notebook, VS Code notebook, and create the connections to the Glue server. That's it. Okay. Stop notebook. And then we had another job. Somewhere we had this on my job. Yeah, we have also this job somewhere. This is probably dashboard for all my jobs. The Glue cost, also worth to know. It's using DPU. It's using this is like unit, I think some data processing unit or so. And you see, depends on the size of the node you choose, it will consume those DPU hours. And then, yeah, that's how it works. And Spark also has, Spark has DBU credits, for example, Databricks units probably. Snowflake has credit. Every tool right now has the credits, and you pay for compute. but also I'm going to pay for S3 separately to store the data. Okay, where is my job? Okay, it's here. So you see its type. So we had the Glue ETL. This is the Spark, and this is just the Python type. So if I open this, it's just a script. And it succeeded. And max capacity logs. If I go to here and to here and see what I get. This is job run details. This is the log in CloudWatch. And this is probably just showing us the script. So the interesting thing to know, if I go to job details, it should tell us. You see, this thing doesn't store the Python code itself, and the Glue Spark the same. So this environment doesn't store your code. Your code is storing in S3. So that's why traditional development path, I can build something in Notebook, and then I can compile just one big code file, like Python file. I can save it in S3. And then I will create the job. I will point to this. And this very interesting thing, what you can do now, because your job is a file and it's free. And if you know, there is, for example, GitHub Tech exist. If you ever work with this, so this is something, and we had the same with ECR images. Like you can push the image, and you can have this is latest, or this is version 1, version 2. The nice thing about Glue jobs, because you have separated files, it's not related to Glue, it's just the approach. You can tagging the files. So, for example, I have the production file v1, and I'm working currently on new file. So I can create the file v1.1, or I can have v like Dimitri underscore v1 as a file name, and I can push it to S3, save it in S3, for example, with make command, and then I can create the Glue job that will look to the new version of the file that I'm going to test it in my dev environment with my dev dataset. So this is basically the same as how you can manage releases. So because you're storing all your files and jobs is actual files, you can apply all the software development like lifecycle things. And in the past we used the tech. So and then another thing I show you, this is using CI/CD. You have the Glue Docker image. So this could be extremely interesting projects if someone wants to do like pet project. There you want to apply the CI/CD process with running testing in the Docker, and then apply the version of the file. Like so, your production version and like your deployment process will depends on the tech. Yeah. Okay. Those two things working well. This one-time cost while it was running, so we good here. Now we can check how's doing agents. Uh, it failed. Can you? Oh, and deploy. Our flow is failed. Okay. Yeah. So it was both of them works fine. We already confirmed it, but it's also running it here. So it started the job, run ID. It took 21 seconds. It saved the file in the output. It's all good. Perfect. So we mark this as a completed. This one, another one with PySpark. Glue run ID. It's even somewhere save this glue run ID. You know, it has the, then you start the job with AWS CLI, it gives you ID. So yeah, you can use this ID to track the status. So if I want to check the status of the job, is it process or succeed or not? So I need the ID. That's why it's saved as ID. So we see it's ID, succeeded. We have two workers, 89 seconds. And this is the commands it's using. So AWS Glue start job, job name, and passing the arguments. And this job ID run is showing us. And remember it ask us if you want to like have the parts. So we're gonna validate what's the part looks like. Uh, okay, so it's Airflow is still keeping working in process. For this one, I don't know. It's trying to do something with data to make it working, but we want to validate. So inside we have this folder, and it should do some kind of like partition things. That might be interesting. So first, if I go job and I go down where we have this we have this function write to S3, and we can see how it works. Let's create DataFrame. Interesting. Where is the write? Oh, it's using this one. So let's check. This is the interesting step. It's using Holesky. So I think it's like reshuffle the data before it start writing this. Let's check. Because in Spark, there are two interesting commands to know. One is call escape, another one I can call repartition. So this one basically, assuming I have two nodes, it means two nodes, each can save the CSV file. What we're doing probably, well, let's just confirm. I have two workers. Does it mean we will merge result into one file. Yeah, so call SQ command will do exactly this. So we have two workers, each has their subset of data, and this command will merge them together as a one file. Because then we work with Spark and multiple nodes, then we should be aware like how many files we read, what their size, and how many files you write. Because, for example, when we start work with Athena or another service down the road, it's also very important what's the size of the file you have and how many files you have, because it's all distributed compute environments. Yeah, that's the thing. That's interesting to know. And it has alternative. The alternative. So CallSQ will do run like trying to merge files back, but repartition, it's actually things that you want to control number of files. It's extremely important. Then you do work with Parquet and you have like 100 gigabytes because your typical Parquet size 1 gigabyte, and through repartition CallSQ you can control your output. That's probably the most important thing for the Spark. And I assume right now with the Databricks and all those managed things, they're trying to manage it for you to make it nice output. But you still good to know these like things. And you see it's just like two commands, but those two commands highlight how the Spark works. And it's come have one file. So you need to, as a data engineer, you need to choose like how to handle this. And if I go, let's check the status of the agent. So this one we done well today. What's about? Okay, it's still doing deployment, and this thing starting do some crazy conversion of the files. Oh, I hope it. I even don't know where it's doing it. So it's create the Python file. So it basically will go over each path and convert JSON types. Maybe it wasn't the best idea to us to create a Athena table on top of the files. Okay, we can check how's the stuff going for Airflow and where it's live here. So your typical pet projects might involve Managed Airflow, dbt, and Snowflake. And then you just need my favorite question interview about dbt and Airflow, how you host the dbt. Because with Managed Airflow, you have two options. Put dbt models in S3, and Airflow will run it, or let Airflow run batch or ECS. So this is very good, like pet projects touching everything. So this is on Airflow. So it's still creating. It will use the S3 bucket where it will store all the DAGs eventually. And that's our goal to make sure Airflow see the DAGs. We need to put this in S3 bucket. So it will have the VPC and subnets. That has the size. We can control worker counts, observers, logs. It has encryption and tagging. And we don't have any configurations options. So this is where your typical Airflow parameters will come up. So here you can, like, if you know what kind of things to add, so all the parameters going to here. Yeah, it's like tuning of Airflow for parameters. You see, you can add the email notifications, because I usually use like Slack notification, but if you want email notification, you can connect it with email, or you probably can just use AWS SQS or SNS service that can do email delivery on if event happened. I don't know how long it will take. Oh, it's completed. 2 year. So it's starting to deploying everything. Okay. And we can check the costs, because I'm using my account. So you see the VPC costs like $7, and it's doing nothing. But probably today we spent a bit money on Glue, and we'll spend a bit money on Athena. Maybe we can ask, okay, what is the Athena cost in AWS? So you pay $5 per terabyte. Any free tier? But you also pay for S3. And S3 is not just storage. It's like you get request, list request. Okay. And by the way, what is AWS Athena? Maybe I will find a diagram. If you ever heard word Trino, it's basically same as Athena, but initially it's all started from Presto. So the Presto was developed in Facebook as a service, as a SQL engine that can read data across different data sources. You can connect it to Postgres, you can connect to S3, to anything you want, and you just query. And then the Presto became like open source outside of Facebook, and they call it Trino. And the Trino is quite popular in Russia, by the way. You can run it in Kubernetes, so it's like it's again like similar idea as a Spark. You have many nodes, but only run the SQL. That's why it's popular. Obviously, because it's SQL, dbt works fine with it. And Athena is basically took the Presto and fork it and create this query service, SQL engine, serverless. You don't mention any infra, you just pay for data you scan, and you read data from S3. That's it. So you can read any kind of data if it's an S3. no, there is no history. And yeah, you see it's Presto engine. So you submit the query and the Presto agent, and it connects, because by default in Trino you need to manage your own catalog, but it also works extremely well with Iceberg. In AWS Glue, you're using Glue data catalog and S3 for the storing, and you like have connection to all the services. Actually, it would be interesting to add the step for the Iceberg data catalog, something among our list of our exercises. So it's still doing something. Yeah, Airflow still in process. Athena still in the process. And maybe we can do here Athena DBT core. Yeah, that's one a bit scary. Athena DBT core, because I'm not sure where we need to put the DBT core. But maybe if we come up with ECR image with DBT, then we can use it for Athena, and we can have the same for Snowflake. Okay, also Airflow. Because what we want to have from Airflow, we want to be able to run Python, and we want to be able to run the glue. So that's like ideal scenario. The downside, every time it takes very long time to do any modifications of Airflow instance. Oh, it finished. Everything finished for Athena, and it's also see it create the database, but it means it create in Glue catalog. It create the tables. You see the DDL for the tables, including the partitions by date, but also very important, because it's JSON, you need like serve the whatever like JSON format and properties. And this is, by the way, was very complicated in the past. If I have JSON files, I need to create a Athena table. I need to find the right properties for this. So the different formatting options. It's all here, and the sample queries. You can copy them. That's about it. If I go to Athena, yeah, Athena is extremely simple service, because it's only SQL and only query the data. This is, we can see data catalog. Interesting. Where is yeah, maybe, yeah, it's requires to know what region you're using. So that's my default catalog. data and database, and I have table, and now I can run the queries and see, and maybe I can start from, I can even click here. It tells that it's partitions. I can see DDL. I don't need to click load partitions because we have projections, but I can click preview table just to get the sample, and that's the sample. You see, it's all our messages from Discord. My goal was to, in backend of Surfalytics, to have like these statistics for, or over like have the weekly email, how many messages was published by, and who is like top messenger, and also make sure people who is not active, like just send them emails. That was the plan. But yeah, because it's all here, and we had top authors by message count. So for this limited, yeah, I'm Nikita, obviously, then Kazar, Max. I don't know where is he. Nikita, you a bit behind me. Yeah, we can see emoji. Yeah, that's the nice one. Yeah, you see, the fire is the most popular, but the custom one with Pepe, unfortunately, it's not showing. Maybe there is the fix to get it working, but you see, the fire is number one. Perfect. Most active channels. And what I'm doing with this data, I using Duck Lake. So it's the same, like your data storing is free, but query, and then for catalog, I using Duck Lake. It's a Neon Postgres database. And then the SQL I can submit with local DuckDB. But basically, it's exactly the same as Athena and Glue data catalog. No, that's amazing what we did today. And it's, if you can understand the connections between things that we're looking, then you're good. You in Glue. So I can go into Glue and see what I have. Tables. So I have this database, Surfalytics Discord, and I have this table, column statistics. No, nothing. I can generate it maybe. Need the role again. Okay, let's see how our flow is doing. Still creating. Okay, while it's creating, so it's great. With Athena, we also finished the exercise. Nice thing about Athena, you don't pay it if you don't use it. So for all the services here from 1 to 11, except the Airflow, you don't pay if you don't use. But Managed Airflow, it's VPC, you pay, it's running itself, you pay, so not good. Okay. Next, I want to work on their DBT core to bring the DBT project to read data that was produced by maybe GlueSpark as a source, and then create fact table. Oh no, actually no. I better do, because we have many queries for this Discord data. So, and maybe we can create dbt projects that gonna like visualize all the data. To use the data from project and convert there, because we have sample queries, into the fact tables and maybe some dim tables. The dbt project will be inside Docker image for Athena and pushed to ECR as a new library, and then when we can run this with flow later. So basically, I want to add dbt, and okay, maybe to make it a bit more useful and complicated, I want to use Iceberg format for my Athena lakehouse to store the dbt fact tables as Iceberg format and something like this. Because now because the exercise now that we have with JSON and Athena is data lake. It's not lakehouse. To make it lakehouse, we need to use the table format different from like this Hive Glue catalog. We need to have Iceberg Delta Hoodie, and Glue catalog works with Iceberg really well. That's why we're gonna do it. So, but now it's the plain mode. And then the nice thing about Redshift, as soon as we have like dbt Docker with dbt in ECR, we can just clone this Docker and update the type to enable Redshift and Snowflake, and then that's it. And then Airflow can run it for all three. So out of these, you will have Redshift with dbt, Athena with dbt, and Athena will be Iceberg, and the Snowflake with dbt. So it's amazing. And then, we need to figure out the streaming with Kinesis. And maybe we add number 16 for later to close all services. EMR Spark job to basically enable EMR Spark job. And I will add git keep in those folders. They will appearing inside. Okay, Time to check Airflow. Oh, Airflow is available. That's great. I open UI. So this is our traditional Airflow. Doesn't have any DAGs yet. In case if you want to save any secrets, variables, or connections, we can do it here. But what we're going to do, we need to push the okay. Did you upload the DAGs to Airflow? And did you add DAGs for Python and for Glue Spark? Job to run. And for my AWS, I will tell that I have yes, and I have the Airflow for this. So it will build end-to-end everything. And we also uploading all the DAGs to the Airflow. Yeah, that's the one. The first one, GitHub to S3 daily. We can check this DAG code. So very simple one. It just will run. So it will call the function, and the function so it's basically calling another Python library, GitHub ingest, instead of putting it here. It's okay. Let's see what else is doing. It's still, and we can see in DAGs. So this file is calling this file, and this is another DAG that will run the Glue Spark, and this is the requirements. We didn't specify any constraints. Build DBT and DAG. Yeah, let's do it. Star schema. Life in Glue. Yeah, somehow mixed the regions. Okay. Okay, maybe what we can do for now, just starting Let's plan the exercise for streaming on AWS to try different services in this folder. What would you suggest as simple exercises? Okay, this tells me all should be good, and we can go and test. We can potentially adding MCP for Airflow, and maybe it's not a bad idea. Let's check. Where is AWS Airflow MCP? Or maybe just let's try tell see. I want to add Airflow MCP for my instance and see if it will be able to add this. Because this will allow to Claude or any other agent directly talk with MCP. The manage Apache Airflow. So task it can let's describe environments, update environments, delete environments, generate access tokens, obviously run and test Airflow DAGs. Yeah. It needs profile, region. This everything we have defined with AWS CLI. And then it will just create this MCP server configuration. And it gives also option you to run this inside Docker container. Perfect. Would be nice if it's let's see where it will add. And while it's working, so we have two jobs here, and we can start from the first one, GitHub to S3 daily. So it's already started the job. If we click the task, we have single task, and it's already failed. It's failed with the error that the bucket does not exist. So interesting. And it's okay. We can just pass this over. And we enable this task too. This now should trigger the Glue job. Go to here, go to logs. And we'll see then it's starting generate logs. So as a reminder, all logs generate in CloudWatch. So it's not yet created the log stream. but it will. Okay, we don't need this. And after the exercise, I will probably drop my Airflow environment because I don't want to pay it. So it will create this file. It will create this file right here in the root. And then every time we want to start the Claude, it will check this file, the same as it checked Claude MD. And then I can chat with my Airflow instance. It's especially helpful and imagine you start your day and say, hey, did I have any Airflow errors? Can you check why? You can check why, and it can create the PR right away. Or you can completely automate this. So you can host somewhere MCP, Airflow failed, and you have alert event, and then it can do everything you want. So you see, it's create MCP. Okay, assuming it's all good. Can you test it? So let's check that if MCP works. And here we can define any other MCP we want. We can do for AWS, for Snowflake, for Redshift. We can create our own. Oh yeah, I need to make it working. I need to exit, and it tells me my previous session. So I will use this session to log in it back. Okay. Can you test MCP? Or I can use /MCP to give me. Okay, it's loaded, available. Okay. I think this one failed. This DAG was failed. Was it failed? Oh, we see the Spark one succeeded in Magic. And you see how fast we did it with agent, right? It's very simple task. We have glue job defined previously, and now we change the schedule such instead of, and we did not touch even schedule from Glue, but we just hook it to Airflow, our idea of like centralized orchestration tool. Notebooks, ETL jobs. So this is the Glue. If we check runs, so we can see that like just several minutes ago there was the run, and that's how it works. Arguments. It doesn't tell us what kind of run it was, who submitted it, but triggered name here and here. But it was the Airflow. We can validate it by job ID. See? You see, that's the job ID. So this is all good. That's great news. What's about this one? This one failed. And we just ask to change. So it's now updating the DAG to make it working. Okay. Yes, build it. We dbt Athena Iceberg lakehouse. Now building it. Oh, and this come up with ideas for streaming services. So data stream producer consumer we want. Firehouse S3 we want. Lambda we want. We want. What should fit the stream with reg? Let's use some synthetic generator. So what we're going to do, we create the plan, and maybe we'll save this plan for the future, because for the streaming, we'll have dedicated full lesson. Maybe next time we're going to finish our DBT stuff around all those services at EMR. EMR is very simple. So EMR is same as a Glue, but instead of Glue, we have EMR cluster where we want to submit the job. And we can use even EMR serverless, same as a Redshift serverless. Nice thing, you don't need to wait while the cluster will be created. Oh, it's still, yeah, it's creating DBT stuff. Okay. Let's run it again and see if any changes. Oh, that was fast. Too fast. But it worked. And it took 6 seconds. Amazing. What a speed. So this one we mark as done, and we even use the MCP server for Airflow. Perfect. I don't know what else you're doing, but we're done with it. We don't want to build this now. Instead, create subfolders for each exercise with a README file with tutorials for newbies to learn concept before build. So yeah, and we can leverage this later. So we'll see how our lakehouse going. It has the Docker file. So it's using Python 3.11 and install dbt core. And that just should has the dbt. Okay. And then in dbt, this is our dbt project. So right now we have dbt project, packages, and the profiles. Okay. Requirements. we use Athena community. We can check what's the most recent version of dbt Athena community. The last version is 1.10. What is about? And we need to check. We use version 1.9. Assuming this one. Yeah, they support Iceberg. That's great. Okay, it will create this. And what I want to do for now, I want to disable I want to destroy our Airflow. From AWS, we are CloudFormation, and we'll start it next time to avoid overspending. Yeah, that's what we are gonna start as a plan mode. Interesting. Did it build Docker? No, it's not. Didn't yet build the Docker. But the approach for Athena DBT is quite straightforward and simple, so we can split it. So first you have Docker container that can access the Athena and run it. The one important step is make sure how DBT accessing Athena, even from Docker. And for this, we define it in profiles. So it will use region, database, and schema threads. But it also need to make sure it has IAM role that it can use to access. So then it's not yet here specified. So it built the image. And if I bring here my DBT things, you can see there is new image, Athena latest. And it's already starting running the models. And feels like it's running well. So the same will happen in Airflow, in Managed Airflow, but this image will then we build to push to ECR, and Airflow will take the image and run it inside ECS, Elastic Container Service, or it could be AWS batch, doesn't matter. And here, all the models, everything running basically for us. I don't know why it's used AMD 64. Nice. For Iceberg is Presto 6 model. Okay. where? Oh, it's still running something. If we go to AWS and see what we have here, there's our single catalog, US West 2. So we have this probably new catalog. Can see there's no much options. Then we have catalog. We have table. We have database. It has location. Column, connections. And we have the most important table format, Apache Iceberg. So if we're going to compare it with, I don't know, maybe a previous one, we don't have even table format. So it was like probably Hive default table format. But now we have the Iceberg table format. It means for us, if we're going here in S3 and see what we have for the Iceberg, so we have two folders. It's very typical for the Iceberg. We have data, it's just our Parquet file, but we also have metadata. And here you have three files. You have snapshot, and you have two other files. So to show you what is Iceberg in nutshell in short. So it will tell us what kind of files we have. And while it's searching it or not searching, we can open the image and see what it has. So we have data files and we have metadata, those two folders we have. In catalog, we have the table that's pointing us to metadata file where it has a manifest file and it has manifest list. It's basically list of the versions. And then you have snapshots in metadata files. So the one like to each one, or maybe this one is showing us in S3. So that's exactly. So this manifest file, like snapshots, it's format Avro, this data file in Parquet. Then you have manifest list in Avro, and you have JSON file, this your metadata file. It has versions of the files. So manifest files, it tracks individual data files and delete files. They also provide statistics, including column value range and help query optimization. Manifest file, list of manifest files that makes a specific snapshot of an Iceberg table at given point of time, and metadata file. So there are basically three things. But the key, Iceberg, it gives us more options and more commands like for delete, updates, and so on. If you decide to do incremental or do some merge statements, now we can do it. And for now, we only have in my new database, Discord Mars, I only have a single table for now. If I go to Athena, and my source tables for DBT, they're not Iceberg. They just JSON files or CSV files, doesn't matter. Yeah, Discord JSON files. But while we're doing transformations and like new layers in data lake or lakehouse, we convert them into the Iceberg format. Because if our storage, like source data, linting data is just append mode only, it doesn't really matter what they have. So recent queries, save queries, editor, save query settings. Where's my queries? Query editor. Should I go here? And recent queries. You can see those ran by myself. I don't see. Oh, we have another work group. So it's like, let's just highlight. We don't even need this one. Athena or groups. So we can isolate the queries. So it's more like for security in isolation. Okay. And you can see here lots of queries, and you can see them. They were submitted by dbt. And you see this because it has this dbt version, profile name, prod node, and like all kinds of things. And this tells us about running the tests because we know it's probably some unique tests. That's super nice. But to be able to read this and understand what's happening, I highly recommend to finish dbt tutorials. And if the only one thing you need to know well, it is dbt. Okay, what it telling us? Docker image. So what it built? Yeah, we saw the dbt projects. You have the staging, you have starting from the sources. And by the way, if you want to pull all the image messages yourself from Discord, let me know. And to Discord community, I can give you the access. You can pull all the messages. So it's lots of data. Nice one. So we have source, just Athena database and schema. So the source is using Athena to query. This is how we parse all the JSON file. And then marts. So we have dim outer, we have outer key, dim channel, dim dates, and we're using dbt utils to generate the calendar. And then couple fact messages, and we schema with definitions. So this one clear. And we can apply this pretty for anything. Athena or Snowflake, Redshift will work fine. And then we have deploy. For deploy commands, we have ECR registry. And I think in infrastructure, CloudFormation, yeah, it's one dbt. So we create dedicated resources like ECR and everything. We have the Iceberg things. Good question. Where did we define that dbt will save tables as Iceberg? Because we have JSON and then Athena writes it, but it saved them as an Iceberg. And you see it's inside dbt project, table type and materialize Iceberg in format Parquet. Then that's how it's understood. And then it basically will add the table properties for each table. Even if I go to partitions, indexes, table properties, partitions, index. So we now have all the tables. Table optimization, schema. You have table type. But in Athena, if I check here, generate table DDL, we can see what's happening. So location. So this thing is handled by Athena. So Athena create this like folder. But table properties, it's here. So from dbt project YAML definitions, from here, it generates DDL under hood. And I know if we have query editor, recent queries, show query table. Do we have any create statements? Yeah, so it's create to replace the view. And this is what dbt does. So it's using the view. Maybe I create or replace create table. Yeah, let's check the create table. And we have here the create table with parameters and then our SQL. So now you know how we handle lakehouse in Athena and dbt. So everything works extremely well. So the one step is missing so far is okay. Did we add a DAG to run dbt from ECS? Let's just adding the DAG to here to run it, and then should be good. And we also probably done with streaming things. So we'll start from Kinesis and a bit of theory for Kinesis to read. Then we'll use the Kinesis Firehose. Then we'll use Lambda as a consumer of the stream. So, for example, you get some file, JSON file, you want to quickly do some modification of this, and then we'll look to the Flink. Yeah, that's, I don't know, maybe number 5 would be additional Kafka, but I'm not sure. So I'm closing this for now. Not yet Airflow. Yes. So let's just make sure we can run our dbt Athena from Airflow. And then that's great. In the past, to build this kind of project, it will take a team of engineers, several engineers, and literally a month or like several weeks. And you see I'm alone and I didn't create this before and just understand the fundamental conceptions, was able to build it. And you see how fast it's going. But the key is the system design. So you need to understand what service is available, what's their pros and cons, what's their cost, and then you can build anything. So it's granting additional permissions to be able to access ECS, and after it should be good. Yeah, and we have all the tables here, all the queries. If I go to Surfalytics Mars, so I have the tables here, and I have the folders. The one thing in the past I had with Athena, every time that run, here it will create new folder and never clean by itself. So kind of like table will pointing this metadata file for Iceberg will point to the new table, but the old one might be, so you can like start duplicating this over and over. That's something to keep in mind. Yeah, let's use MCP Airflow to run it. So we can see here we should get the new, oh no, it's not yet new. So it's added this DAG to run. Tunable from Airflow. And what it using Airflow providers, a ECS one, ECS run task operator. And it trying to get variables from the DAG, and I think we had same issue with S3. It should be just hard coded. So it's running Iceberg. Okay. Don't use variables. Use this values. Don't use Airflow variables. Wireless in Python vars and upload that. So it will upload in S3. And in terms of repos, if you host this in production, so technically you will have one repo for Airflow, one repo for infra, and one repo for DBT. So 3 repos to run your project. And then you have maybe the 4th repo if you have some kind of like data ingestion, so totally 4 repos. And you can have additional repo, for example, if you want to have data quality, for example, using Soda or something else. And then, or maybe you have the data catalog with open metadata, and then you have additional things. Still required. Yes. Add this to the flow role. It is defined in and we see is here around task operator. What is it? Let's see it here. And this like documentation about these and parameters it takes. But this is the most traditional way to run dbt and Airflow. Every second company that I know here in US and Canada, they're using Airflow and they're using dbt core ECS. Almost no one using dbt labs. Okay, it will update stack, basically just only updating the role. Okay, and we can ask Claude based on the repo what else is missing for data engineer in AWS service. Maybe it will suggest us something. Okay, it's grant additional permissions and deploy them. Okay, I can unpause and run it. So DAG is here. No, DAG is not yet here. Upload DAG to S3. So it's using AWS S3 DAGs to see if it's uploaded. Yeah, fix it. So what ideas it tells me is missing? It's covered, incomplete, etc. Step functions, no code. README only, no code. Why you tell me no code? Oh, but yeah, we have it during the demo, and it probably just have deployments. Event reach, step functions, yeah. Empty, okay. Oh, DMS, CDC, RDS error, change data capture from relation database. This is actually not bad idea. Stream trigger processing. Upflow, I'm not sure we want to have it. Lake formation, no. Who did it? No. Glue data quality, no. Dashboard alarms. That's nice, but it's very easy to check ourselves. Sharing, no, this Redshift, copy spectrum. Okay. CI/CD, Terraform, testing. Yeah. what we can do here, okay, let's add MSK to there as 05 inside, and let's add 17 DMS CDC from RDS and 18 DynamoDB. For now, just add the README files with simple steps size we will use. I agree that it's very common case with RDS, either from traditional database, and again, you can use the DMS, you can use directly Airflow to pull the data from RDS, and so on, and DynamoDB for NoSQL too. Okay, did you do everything you need? Yes, it is here. One just to make sure it is starting. Oh, it's failed out of. Oh, let's give it. Yeah, just took something wrong. Let's start it again. So under hood, it should take the image from ECR to go to ECS and start doing something. This is clusters. Okay. Oh, what's this one? Yeah, it's using this one. It has this task that is running now. See if it has logs. You see, yeah, logs is here. So it's run. And it's running it too here as well. So it's great. It's all running. And maybe it's running it here too. Yeah. running the tests and everything. We'll see if it will create eventually we'll create a new table. Score, name date. So it's completed. Everything succeeded. Super nice. I can close all of these. Always. Task succeeded. The cluster. Yeah, the cluster shut down. Athena done with the querying. Dim date here. So it's updated. Yeah, 2 minutes ago. Yeah, it doesn't have any old version of the stuff. It's good. What we can do if I say, hey, yeah, it worked. Can you analyze these Iceberg metadata files and tell me what it has? So it means we successfully run our DBT on Airflow and we built the Iceberg lakehouse. It also we added extra steps for the future. What we're gonna do there? Okay, we can tear down our Managed Airflow, and then we added extra steps. Let's use a hub and add a PR with extensive comment what we added today. So GH, it's a GitHub CLI, and yeah, we can push. We see lots of changes today. We can push it. Yes, auto mode. Let's. Yeah, maybe I should keep the buckets, but yeah, it was too rush because I only did drop the compute, but it's okay. We can recreate it, everything in the future. Okay, close this. Okay, it's deleting. And this will push everything in pair. You can see how nice the PR was. Yeah. Let's edit exercises, edit extra steps, edit the YAML files. Perfect. Okay. We can close this one. This one's still deleting. We can close this one. Yeah, that's basically it for today. We did a lot of cool stuff. And next time we will keep going. We do Redshift and Athena. And maybe we'll do both Redshift serverless and traditional Redshift to highlight concepts. And, oh no, Redshift and Snowflake and EMR. And after this, we can jump to the streaming and change data captures. That's it. Thank you.